Now I will show you guys how we can use the formula that we got from the other video to get the curvature for this curve. And notice this right here is just a helix because the I and j component, they form a circle with radius a, and then the k component, we have t to the first power times a constant b. So just imagine it goes out like this. And we also have the conditions that a and b are non-negative and a squared plus b squared is not equal to 0. This is just we are ensuring that a and b are not equal to 0 at the same time, because otherwise we will have just 0. And recall that the curvature kappa is equal to the magnitude of v cross a, and then we will have to divide it by the magnitude of v raised to the third power. So let's just go ahead and get this started. I'm just going to work it out along the way. Here, let's just start with v cross a. This right here, we are going to set it up in this 3x3 matrix determinant, and we are going to start with the I component here. What we are going to do right here is just differentiate this so we can get the I component for the v. So take the derivative of this, we get negative a sine t. And then to get the I component for the a, just look at this and take the derivative again. So we will get negative a cosine t. And then let's just do the same thing for the j component. Differentiate this, we put it here, a cosine t. Do it again, we get negative a sine t. Lastly, for the k component, take the derivative of this with respect to t, we get b. And then do it again, we get 0 because b is just a constant. And now we just have to get the determinant of this. That's how we do the cross product. I'm just going to do it the standard way. So start with I, let me put it down right away. And remember, when we do the cofactor expansions, we have the plus minus plus. So the first part is positive I, yeah. And then we are going to delete this, delete that. Look at this part and do the determinant of the 2x2 matrix. To do so, we are going to do this times that, which is just 0, and then minus this times that. That's negative, so that will make this positive. And then we will have a b sine t. Continue, here we have the minus, and then we have the j, and then we are going to delete this, delete that. So focus on this, and that. Take this times that, that's 0. Subtract, take this times that, that's negative. So we will get positive here. And then we get the a, b cosine t. And then plus k. Delete this, delete that. Take this times that. That will give us positive a squared sine squared t, and then subtract this times that. That's minus, so we will make this positive. And then we will have a squared cosine squared t. This right here is pretty nice because we can factor out a squared. And then we are going to see our good friend, namely sine squared t plus cosine squared t. And you know, this is the one that we love. So we get a squared times 1, which is just going to be a squared. So all in all, we are going to get ab sine t in the I component. And then right here is negative times that, so it's minus ab cosine t times j. And then finally plus just a squared times k. Okay, now we are going to look at this, and then we are going to find the magnitude of it. So the magnitude of v cross a. Okay, this right here is equal to, we open the square root first, and then we are going to square the first component. So ab sine t, square that, and then we are going to add that with the second component squared. Technically here it's going to be a minus, then square, and lastly, we also have to square the a square. So a square and then square that. Okay, let's see if we can simplify anything. Hopefully, huh? So this right here is just, we have a square, b square from both of this. We can factor that out. So from here and here, we get a square, b square. Notice we will have sine square t plus the negative go away because it's just squared. And then here we are going to see our good friend one more time. This is the one that we always love. So this is just equal to 1. So it's just a square b square times 1. Okay, and then here we have a to the 4th power. So this thing is equal to the square root of a square b square plus a to the 4th power. And perhaps we can simplify this a little bit. We can factor out a squared. So that will be this, a squared times, here we get b squared plus a squared, and then in the square root. So we can just do the square root of the first and the square root of the second. And because a is non-negative, when we take the square root of a squared, we will just end up with a, and then we take the square root of this. But of course, we should write a squared first, right? It looks better this way. Okay, so this right here goes here. So that's what we have now. Then on the bottom, we will have to divide it by the magnitude of v and then raise that to the 3rd power. So let's see. For v, of course, we'll just get the derivative. So that is negative a sine t I, and then we add a cosine t and then j. And then finally, we have to add b and then k. Let's go ahead and take the magnitude of this, which we'll just have to do the square root, and then we are going to square each component. So negative a sine t, square that, and we add this, which is a cosine t squared, and then finally we add b squared. Are we going to see our good friend? You bet. Of course. Right here, this is going to be a squared, so we can factor that out. And then for the first part, we get sine squared t, and then for the second part, we add cosine squared t. This is the one that we love. So a squared times 1. So in fact, this right here is just going to be equal to square root of a squared plus b squared. Yep. And we just have to put this right here and then raise that to the 3rd power. So we will have this to the 3rd power with square root of a squared plus b squared. So what does this mean though? Well, you can write it down like this. A square root of a squared plus b squared over, I'm going to first write it down right here, square root of a squared. Let's just do it the good way. Write this down 3 times. Why? I don't know. I just feel like doing that. So we can go ahead and cancel this and that nicely. And we can see that this times that is just the inside. So ladies and gentlemen, our curvature kappa is equal to a over just a squared plus b squared, which is a very nice expression in my opinion. Okay?